Today we're going to split 10.4 into two sections. I just don't want to really rush through it. In 10.4, we're going to find the surface area and volume of similar solids. So today we're going to focus on the volumes of similar solids. Before we get into example 1, I just wanted to make an official announcement that this is the last lesson of our textbook. That's awesome. Yay. We're going to do, remember I told you, we're going to do a review packet for your end of course exam. So that'll start on Monday. And then we're going to do an inequalities unit, which I'm almost done with, and then some factoring. And then it'll be time for your final exam. So all of that will be really helpful to you as you move into Algebra 1. What's that? Like 6? 5 or 6? Okay, so in example 1, guys, what it's asking is which cylinder is similar to cylinder A, okay? And what I need to look for is I need to look for the ratio of their side lengths to be the same, or not side lengths, but the dimensions in the figure, okay? So on this figure, I need to put the dimensions of cylinder A into a ratio. Well, if you remember, a ratio can be written in 3 ways. Using a colon, the word to, or a fraction. We're going to use fractions. All right? So how could I put the dimensions from cylinder A into a fraction? There's actually 2 ways that I could do it. Maya?
6 over 4.
Exactly. 6 over 4, 4 over 6. I did 4 over 6 just because I like proper fractions. Okay, 4 over 6. But what you have to be mindful of is 4 is what dimension? It's the
Height.
It's the height of the figure. 6 is the radius, okay? So for cylinder A, does everybody agree I did height over radius? Height over radius. Okay? All right, so for cylinder B and C, guess what I have to do? Height over radius. If I switch it up, then I'm not actually doing a true comparison. Okay? Also, I need to make sure it's reduced. Is 4, 6 reduced?
No.
What is it reduced to?
2/3.
2/3, okay? So if I can find one of the 2 other cylinders that has a reduced ratio of 2/3, it means they're similar. All right, so let's go ahead and try cylinder B, okay? Ratio for cylinder B, guys. What is it?
3 over 5.
3 over 5. Go ahead and find cylinder B or C now. Have you found cylinder C, guys?
Yes.
All right. What's it going to be?
2/3.
5 over 7.5. And yes, that reduces by 2.5 to 2/3. So because of that, I can clearly see that A and C have the same ratio. All right, now on your homework tonight, you have 5 problems. 2 of them are identifying whether or not figures are similar. Guess what? They're not cylinders. Okay? They give you different dimensions. All right? So what you have to do, and we'll go over it more in a minute. Oh, man, I could have done the extra example. Let me see if I can add in the extra example to the end. I think that'll help you more. But basically, you put each matching side length into a ratio and make sure they all reduce to be the same value. All right? Let's go ahead and move on to example 2, and then we'll try to come back to that concept. That'll help you on your homework. All right, so in example 2, we're finding the missing measures in similar solids. Finding the missing measures in similar solids. So what we want to do now is we want to start with cone X and just put cone X into a ratio. All right, go ahead and put cone X into a ratio. There's 2 ways you could write it. Either way is going to be fine. Okay, what's going to be the ratio for cone X?
5 over 13.
Okay, I said 5 over 13. Okay, you could have said 13 over 5. Here's what has to match up for cone Y on the other side. If you do 5 over 13, which is the radius over the slant height, it has to match up on the other side. Okay, so radius over slant height equals, what's the radius for cone Y? 7 over L. Okay, for some reason they used a cursive lowercase l for the variable there. Okay, I think that variable stands for slant height. All right, so now I have to solve the proportion. Well, what you can do is you can do cross products. All right, last year you learned 3 methods to solve a proportion. We're just going to use cross products. All right, 5 times L is 5L, and 13 times 7
equals
13 times 7, well, what's 12 times 7?
That's
84, and then just add 7 more.
negative 91.
91. Okay, now how could I solve for L? How could I solve for L? Divide both sides by 5. And L equals 18.2. Okay, 18.2 yards. Don't forget your label. All right, we're going to do one more example, and then we're going to start on your homework. Okay, you guys ready? Is this making sense, guys? How we put from one figure, we put it into a ratio, the other ratio matches up. All right, Jace?
What time do we get off?
10 o'clock. Okay, all right, so now let's look at this one. Now we have 2 unknown dimensions on the small cube. Okay, we don't know the width or the length. All we know is the height. All right, so it's going to take 2 sets of proportions to solve. It technically does not matter which one we start with. Okay, so let's just pick one. Let's start with L. That we want to solve for L. Well, that means we need ratios that would match up a side length on the big figure with the L side length on the small figure into a proportion. All right, so there's 2 different ratios that you could use for the big figure. Does anybody think they know one of the ratios I could choose for my big figure? And remember, on the small figure, I need to solve for length. Mason? Okay, so he said 11 over 20. All right, why do you think he picked 11 and 20? Why not the 8, Sherelle? Very good, because you can't have 2 variables. If he had said 11 over 8, it would have been L over W on the other side. You can't have 2 variables that you're solving for. All right, so he accurately picked 11 because that will match up with L, and 20 matches up with 8 on the other side. So 11 over 20 equals L over 8. And now I'm ready to do my cross products and solve. How are we doing on this? Josh, how are you doing on this? Anthony? Doing okay? Trey? All right. All right, go ahead and do your cross products. Okay, so we do our cross products. And we get 88 equals 20L. Divide both sides by 20. And L equals 4.4 inches. All right, now I want you to solve for W. Go ahead and solve for W. Okay, Maya, what's the ratio you used to solve for W for the big cube? Which one did you use? Okay, so she said 8 over 20. So if she said 8 over 20 on the first one, can someone tell me what would be the ratio on the second one then, Josh? W over 8. Does everybody agree that those sides match up with each other? Yes. Absolutely. So 20W equals 64. Divide both sides by 20, and I'm good to go. W equals what? 3.2. Anybody's glad that we're done like rounding for a little bit? I feel like all we did in the last unit was just round every single answer. Approximate this, approximate that. It's just nice to see an answer work out for once, isn't it? Okay, so it's not just me. All right, okay, so let's look at your homework questions. I just want to help you out a little bit on your homework, give you a little bit more direction. let's do number 7. Number 7 is very similar to number 8, and I think it's going to help you on number 10 also.
So we can start right now.
Yeah, we're getting started on homework, but I want to do number 7 with you guys. Okay? All right. Number 7 is not on your homework, but it will help you with your homework. That's what I'm saying. Okay? Hey guys, look at number 7. Okay? Number 7, remember how we were putting like the first figure into a ratio? Well, how many values are in the cube on number 7? There's 3 numbers, right? On number 7, well, can you put 3 numbers into one fraction? No. So here's what you're going to do on number 7. Let's look at the number 3. I'm going to put into a ratio the corresponding side to 3 inches on the big figure. So look over to the big figure now on number 7. Which side corresponds with the height of 3 inches? 9 inches. So put that into a fraction and reduce it. Okay, so it's 1/3. So now all the other side lengths have to be that value. Okay, so now let's do the 1 inch side. Well, which side corresponds with 1 inch on the big one? 3. Okay, so I'm good. I've got 1/3 and 1/3. So now let's do the third side. Which side corresponds with 2 inches? 6 inches. What does that reduce to? 1/3. So everybody agrees that all 3 of them reduce to 1/3. Okay, so because they all 3 reduce to 1/3, I say yes. Now, you can't just say yes or no. You have to have the work there showing all 3 fractions. So when you do number 8, if you put all 3 of them into a fraction, the corresponding sides, and they're not the same fraction, you're going to say no. Okay? So that's how we would do 8 and 10, and that should help you. And that's it for part 1 of 10.4.